In this video, we are given some trigonometric equations, and we are going to prove that they are not trigonometric identities by producing a counterexample. In other words, we're going to show that they are not always true by coming up with an example that is not true. For this concept, I'm going to assume that you have memorized this set of trigonometric values. Alright, make sure that that is true. Make sure that you have committed to memory everything on the screen right now. Okay, so I could almost pick any angle at random, and it might be a good choice to prove that this is not valid. I could accidentally pick one value, maybe that will work, but I'm pretty much going to pick something at random. So I'm going to go with letting theta equals pi over 6. I'm going to try that for all of these problems and see what I get. So for number 11, that makes the sine of pi over 6 times the cosine of pi over 6 equal to the cotangent of pi over 6. Well, sine of pi over 6 is 1/2, and cosine of pi over 6 is radical 3 over 2. Now, cotangent of pi over 6, let's glance at the chart. Cotangent is the reciprocal of tangent. Okay, tangent of pi over 6 is 1 over radical 3. So cotangent would be the reciprocal, which would be radical 3 over 1, or better yet, simply radical 3. Alright, so the cotangent of pi over 6 is radical 3. Now, multiplying these two together, we get radical 3 over 4. And radical 3 over 4 does not equal radical 3. So there you go. There's a counterexample proving that this is not an identity being a statement that is always true for all angles of theta. Okay, let's do it again for number 12. Let's again try pi over 6, which is my favorite angle. So sine of pi over 6 plus the cosine of pi over, cosine of pi over 6, I meant to say. And does that equal 1? Well, the sine of pi over 6 is 1/2. I'll go ahead and say it does not equal 2 because I have faith in the process. Cosine of pi over 6 is radical 3 over 2. These already have like denominators, so we can add these up. So this is going to make 1 plus radical 3 all over 2, and that clearly does not equal 1. So we've done it again. We have proven that this is not an identity. Alright, what else you got? Okay, you guessed it, I'm going to do pi over 6. So the sine of pi over 6, tangent of pi over 6, and I'm going to go ahead and say is not equal to the cosine of pi over 6. The sine of pi over 6 is 1/2. The tangent of pi over 6 is 1 over radical 3. The cosine of pi over 6 is radical 3 over 2. If I multiply these two together, I'm going to get 1 over 2 radical 3. If I rationalize the denominator by multiplying the numerator and denominator by radical 3, I'm going to get radical 3 over 6, which is not equal to radical 3 over 2. Alright, there again, non-identity. Okay, I think we're at the end. Alright, this is the last problem. So let's see, sine of pi over 6 plus cosine of pi over 6, and let's see why that does not equal the tangent of pi over 6. Well, sine of pi over 6 is 1/2. Cosine of pi over 6 is radical 3 over 2. The tangent of pi over 6 is 1 over radical 3. These are like denominators, so that'll be 1 plus radical 3 over 2, which does not equal 1 over radical 3. Hey, if I rationalized the denominator here by multiplying the numerator and denominator by radical 3, just in case somehow that will magically turn it into something like this, let's see what would happen. Well, that would be radical 3 over 3. And these are clearly not equal, so again, we have proven using a counterexample that this is not an identity.